Today on Engineering Newswire, we're testing out the latest modular military robot, brushing our teeth with a Bluetooth-connected toothbrush, and developing the world's first child-sized exoskeleton. For some of you, brushing your teeth may seem like more of a science than it should be. No matter how many times you brush your teeth each day, you still keep getting cavities. But it may be that you're repeatedly missing a tooth, not applying the right pressure, or just have bad luck. Thankfully, the recently announced Sonicare FlexCare Platinum connected toothbrush from Philips is designed with sensors that track your brushing in real time. In fact, the sensors can not only detect the location of the brush within the mouth, but also the brushing technique and pressure being applied. This new technology means you can now know which pesky molar you've been missing. The brush connects to an accompanying mobile app via Bluetooth, allowing the data produced by the sensors to produce a personalized 3D mouth map. Users will be able to visually see whether they are brushing too fast or too hard, identify the missed spots, and even be coached on improving their brushing technique. After you're done brushing, a post-brushing analysis will show you areas of improvement. Plus, reminders to focus on those areas can be provided on later occasions. Unfortunately, for those of us with dire need of a little oral assistance, there is no word yet on whether the brush will be made available. Here's to hoping all of the cavities are soon a thing of the past. Brush, brush, brush.
Israel has just introduced a new autonomous military robot featuring interchangeable modules that can be adapted for various deployment scenarios. Robattle is a six-wheeled unmanned ground vehicle developed by Israel Aerospace Industries. Its independent suspension allows the vehicle to scale rocks and small walls to access areas that may be out of reach for other robots. Additionally, a modular robotics kit enables the robot to be altered with different types of equipment and weapons for whatever mission it faces. For example, Robattle's tires can be switched for tank tracks, and it can also be outfitted with various sensors, vehicle control, navigation, and real-time mapping. According to the developer, operators can equip the vehicle with different payloads like manipulator arms, intelligent surveillance, and reconnaissance sensors and radar, and remotely controlled weapons. Robattle even has a lightweight remote weapon station called Pitbull, which includes a range of sensors that can help the robot see in daytime, nighttime, and in limited visibility operations. Due to all these impressive features, the vehicle is suited to a broad range of applications, such as intelligence, surveillance, and armed reconnaissance missions, as well as convoy protection, decoy, and ambush and attack operations. With this new technology, Israel hopes to maximize military operations while enhancing the safety of its troops.
We've seen exoskeletons before, but nothing quite this small. Researchers from the Spanish National Research Council have developed a mobility-minded exoskeleton for children. The aluminum and titanium-based telescopic exoskeleton was developed for children between the ages of 3 and 14 living with spinal muscular atrophy. What makes a 26-pound exoskeleton so revolutionary is that it not only can help wearers walk, but engineers say that it could also be used as a type of muscle training therapy to work against the side effects of the disease. In fact, the exoskeleton includes intelligent joints that modify the stiffness automatically and adapt to the symptoms of each child at all times. The device, which has a 5-hour battery life, is comprised of a series of long supports, known as orthotics, that adjust and adapt to the legs and torso of the child. 5 motors are housed within each leg, which act as artificial muscles, supplying the correct degree of articulation and movement to the legs. In addition, sensors and a tiny onboard computer are able to detect even the slightest intention of movement and send these orders to the motors. The researchers hope that the exoskeleton will someday allow children with spinal muscular atrophy to gain more independence and mobility.
Do you have story ideas? Comment below and we'll cover them in an upcoming episode. For the PD&D channel, I'm John Minnick, and this has been your Engineering Newswire.